This is Algebra 2 study guide for Chapter 2 test. That's going to be Thursday for 1st and 5th period and Friday for 6th period. I'm going over type E problems, which is graph the following equations or inequalities. Number 11, we have y equals negative 2 over 3x minus 3. This equation is in slope-intercept form. It follows the form y equals mx plus b. Just by inspection, you can see that the slope of this line is negative 2/3, and b has to equal negative 3. Since b equals negative 3, the y-intercept is at 0, negative 3. Okay. Next thing you do is go ahead and plot the y-intercept, which is right here at 0, negative 3, and then follow the rules of slope. We have rise over run, so negative 2 in the numerator of the fraction for the slope means go down by 2. Positive 3 in the denominator of the slope means go to the right by 3. So go down 2, 1, 2, to the right 3, 1, 2, 3. Here's your second point. This is an equation, so there's no shading. You don't have to worry about a solid or dashed line. This one is just a solid line going through 0, 2 with a slope of negative 2 over 3. And this is an example of a line that is falling. Okay. Number 14, we have an absolute value equation. What I mean by an absolute value equation is I see these absolute value signs and it happens to be an equation because there's an equal sign. This follows the form y equals a times the quantity or times the absolute value of x minus h plus k. First step you do is find what a, h, and k are. Okay. A in this case is the number right in front of the absolute value bar, that's 3. H, now the tricky one's h because of the negative sign in the form. That means that since this is positive 2 in the equation, the only way to get positive 2 by substituting in the form is using negative 2. I like to think of it as you just take the opposite for h, but negative 2 is h, and then k, the term at the end, 1. Okay. Next thing you do is identify the vertex. The vertex is always at hk, therefore the vertex is at negative 2, 1. Plot the vertex, negative 2, up 1. There's the vertex. Look at A. A tells me whether it opens up or down. Since A is positive, that means this is a right side up V, and this can follow the rules of slope. But you want to have a V that goes like a right side up V. So 3 over 1, positive 3, go up 3. To the right 1, go up 3. To the right 1, here is your second point. I usually like to draw an axis of symmetry because these absolute value graphs are symmetrical. And then this point that the second point that we just found by using A, going up 3 over 1, is 1 unit away from the axis of symmetry. Since it's 1 unit away to the right of the axis of symmetry, for this to be symmetrical, the second point needs to be on the left, 1 unit away from the axis of symmetry. This is an equation, so you want to just draw lines, or actually rays, extending from the vertex. So here's one, and here's the other. And this is the graph of the absolute value equation. Y equals 3 times the absolute value of x plus 2 plus 1. Okay. Now let's go down to 12 and 15. 12 is a linear equation, however it's in standard form. Standard form is ax plus by is equal to c. And one easy way to graph this line is to find the x and y intercepts. The y-intercept is when x equals 0. X-intercept is when y equals 0. So what I do is the cover-up method. You can cover up x to look for the y-intercept. You're left with 2y is equal to 12. The way you solve for y is divide by 2. That means y has to equal 6. That means the y-intercept is at 0, 6, because when I covered it up I essentially made x 0 and I just looked at this one-step algebraic equation. Next thing you do is we got to find the x-intercept. That's when y is equal to 0. I'm just going to use my pencil. When I cover up y, I have 4x is equal to 12. Okay, to solve for x, divide by 4. 12 divided by 4 is positive 3. That means the x-intercept is at 3. 0. Okay. Let's plot the y-intercept, 0, 6. So 0, 1, 2, 3, 4, 5, 6. That's the y-intercept, or actually I got from this point right here. 3, 0, 1, 2, 3. Here's the second point. 3, 0. That's the x-intercept. I have 2 points. That's all I need to draw a line. I'm going to go ahead and draw this line. Make sure to put arrows at the end. And this is not an inequality, so there's no shading. However, 15 is an inequality. What I mean by inequality, look at the symbol. The symbol changed from an equal sign to a less than or equal sign. And inequalities include greater than, less than, greater than or equal to, and this sign less than or equal to. But this looks really similar to the form y equals a times the absolute value of x minus h plus k. And the first couple steps of graphing inequalities is essentially the same as like 14. Remember 14 down up here? You have to identify a, h, and k, but there's a couple extra things you do at the end when you start shading. Okay. Looking by inspection, looking at the absolute value inequality, y is less than or equal to negative 2/3 times the absolute value of x minus 4 minus 8. You can see that a has to equal negative 2/3. H, okay, remember the form has a negative. You take the opposite. This looks like a negative 4, but h is really a positive 4. Okay, and then k, it's the term at the end, or the constant at the back, negative 8. Okay. Next thing you do is plot the vertex. The vertex is always at hk. Therefore, 4, negative 8 is my vertex for this. So I'm going to go ahead and plot that. 2, 3, 4, down 8. 1, 2, 3, 4, 5, 6, 7, 8. There's the vertex. And I'm going to draw an axis of symmetry like so. And then looking at my a value is negative 2/3. This is actually an example of an absolute value inequality where the v opens down because a is negative. So I'm going to go ahead and follow the rules of slope. I'm going to go down 2 to the right 3, down 2 to the right 3, and there's my second point. Okay, and then this point is 1, 2, 3 units away from the axis of symmetry. You can think of it as the run also, from the axis of symmetry, and then to make this symmetric I gotta go 3 units the other way to the left. And before I draw my lines, I look at the symbol. If it's a less than or equal to or greater than or equal to, we use a solid line. If it's less than or greater than, we use a dashed or dotted line. Okay, go ahead and draw this line. We're going to use a solid line because it's less than or equal to. Little arrows. And then by looking at the sign, less than or equal to means everything below the line, or in this case inside the V. However, you always want to be absolutely sure, so we could take a test point. You want to pick a point that's obviously above the lines and below, or below. I'm going to pick 0, 0. That's my test point. Okay. By looking at this, I know that I'm going to shade below, but I want to make sure. So if I take this test point 0, 0 and substitute it back into my absolute value inequality, I should get something that's not true, or a false statement. So let's go ahead and try that. I'm going to put in 0 for y, less than or equal to negative 2/3, and x for 0, 0 minus 4, and I'm going to make that an absolute value sign out of parentheses, minus 8. Okay. And here 0 minus 4 is negative 4. Absolute value of negative 4 is positive 4, so I have 0 is less than or equal to negative 2/3 times 4 over 1 minus 8. 0 is less than or equal to, we have a fraction, so we will multiply across 8, negative 8 over positive 3 minus 8. I'm going to make a common denominator, and I'm going to get negative 8 over 3 minus 24 over 3. Okay, and there's still 0 on this side. and I'm going to go ahead and combine this fraction, but I'm going to bring it up here because I'm kind of running off the screen. Or actually, I can probably just move this over. And what I get is negative 8 minus 24 is negative 32. I'm just going to subtract the numerators, keep the denominator the same. It's greater than or equal to 0. Negative 32 over 3 is in between negative 10 and negative 11. It's actually negative 10.666 repeating. However, it's a negative number, and it's saying that this negative number is greater than or equal to 0. Well, if we look at the number line, all the negative numbers on the left side, okay, they're not going to be greater than or equal to 0. This is a false statement. Okay, that means I don't shade the region that the 0, 0 came from. I actually shade the opposite region. 0, 0 is on the outside of the V or above the line. What we do is go ahead and shade inside and below. Okay. All right, let's go to number 13. Number 13, we have y is greater than 3/4 x minus 3. This is really similar to y equals mx plus b, or slope-intercept form. By inspection, we can see that m is equal to 3 over 4, and b is equal to negative 3. That implies that 0, negative 3 is the y-intercept. Okay, go ahead and plot 0, negative 3. There's that. Use the rules of slope. Go up 3 to the right 4. 1, 2, 3 to the right 4. 1, 2, 3, 4. Here is my second point. Before I start drawing my line, this is an inequality because it has an inequality symbol. This is greater than. We're going to use a dashed line. Okay, so a dashed line. Like so. And then looking at the symbol, it's greater than. That means I'm going to shade above the line. So I want to be absolutely sure. I'm going to pick 0, 0 again as my test point. And by picking 0, 0, I can substitute into my equation 0 greater than 3/4 times 0 minus 3. Anything times 0 is equal to 0, so that goes straight to 0. 0 minus 3 is negative 3, so 0 is greater than negative 3. Hey, that's a true statement. I picked it from this point, or I got these values from this point, which is above the line. Therefore, what I'm going to do is shade everything above the line. And that what that means is I can take any point in this shaded region and it will satisfy the inequality. You never want to pick a test point that's right along the line, because that doesn't really help you. You can't tell whether you're going to shade above or below. Pick a point that's obviously above or obviously below. Alright, 16. Negative 3x minus 6y is equal to negative 18. Let's go ahead and graph this real quick. This is an equation in standard form. I'm going to do the cover-up method. When you cover up, make sure you include the sign, or make sure you don't include the sign that's right in front of the term that you're trying to find. So, for example, I'm covering up x because I'm looking for the y-intercept. I'm saying x is equal to 0, but I still have this negative 6y is equal to negative 18. Include the negative. That's from a different problem. Negative 6y is equal to negative 18. Divide by negative 6 to both sides of the equation. You get y is equal to negative 18 divided by 6 is a positive 3. That means the y-intercept is at 0, 3. Cover up y, and you get negative 3x is equal to 18, or negative 18, I'm sorry. Divide by negative 3 to both sides, you get x is equal to 6, which implies, running off the page again, that the x-intercept is at 6, 0. Okay, let's go ahead and plot this. 0, 3 is this point right here. 6, 0, 1, 2, 3, 4, 5, 6 right here. Have an equal sign, so we're going to go ahead and just draw the line like so. And that's your linear equation. Negative 3x minus 6y is equal to negative 18. Thanks for watching.